Hello students, in this video,
Exercise 9.4, question 18. Limit x tends to infinity, x into 3 power 1 by x plus 1 minus cos 1 by x minus e power 1 by x. Now, whenever you have x tends to infinity, you make sure that x is in the denominator. This x, if you substitute x as infinity, it will become infinity into infinity type. So let us rewrite this. Let us substitute 1 by x as y. So x will become 1 by y. Now when x tends to infinity, when x becomes infinity, y will become 1 by infinity. So y is 0. Y tends to 0. 1 by infinity is 0. So this will change to now limit x tends to infinity. We are going to write y tends to 0. X, you are going to write it as 1 by y and 3 power y. 1 by x is y plus 1 minus cos y minus e power y. Here we are going to use three formulas. That is, first one is limit y tends to 0, 3 power y minus 1 by y is log 3. Log 3. X tends to 0, a power x minus 1 by x is log a. That is the first formula. Second one is limit x tends to 0, e power x minus 1 by x is 1. This is the second one. Third formula that we are going to use is limit x tends to 0, 1 minus cos x by x is 0. So limit x tends to 0, 1 minus cos x by x is 0. So we are going to use these three formulas here. Is equal to limit minus 1 is missing here. There is no minus 1. Let us add and subtract minus 1. Okay, so this is, we are going to use these three formulas. So we are going to use a power x minus 1. The minus 1 is missing. So let us add and subtract minus 1. So minus 1 plus 1. Already this 1 is there. 1 minus cos y minus e power y. Now write this as limit y tends to 0, 3 power y minus 1 by y plus 1 minus cos y. We can group these two. 1 minus cos y by y. Then we can write minus this e power y and this one. So minus e power y minus 1 by y. So we can write like this. We can rewrite this like this. 3 power y minus 1 by y. 1 minus cos y by y. Then e power y minus I have taken out. So minus outside. So e power y, this 1. So we can write as minus 1. Minus into minus plus 1. So these two we have grouped. This and this and 1 minus e power y. So this is equal to, when you apply the limit separately, limit y tends to 0, 3 power y minus 1 by y plus limit y tends to 0, 1 minus cos y by y minus limit y tends to 0, e power y minus 1 by y. So we have these three formulas that become log a. First one will become log 3. This will become 0 because limit x tends to 0, 1 minus cos x by x will become 0 minus e power y, e power x minus 1 by x, limit x tends to 0 is 1. This will become 1. So the final answer is log 3 minus 1. 19th question. Limit x tends to infinity, x log x plus a minus log x. So we cannot apply the limit straight away. When you put x tends to infinity, it will become infinity into infinity. So let us bring this x to the denominator. For that, limit x tends to infinity, log x into, apply the quotient rule here, log a minus log b. Log a minus log b is equal to log a by b. So it will become log x plus a by x. Log x plus a by x. So it is equal to limit x tends to infinity. We are going to bring this x to the denominator. So this is log, divide x by x is 1 plus a by x. So that is equal to, so this is limit x tends to infinity, log 1 plus a by x. You can write this x here as 1 by x. Take 1 by x as y. Put 1 by x as y. When x tends to infinity, 1 by infinity will become 0, right? So when x tends to infinity, y tends to 0. So this will become now limit y tends to 0 log 1 plus a into 1 by x. 1 by x is y. So a y by y. But the formula is limit y tends to 0 log 1 plus y by y is equal to 1. So if I have y here, I should have y here. If I have ay, I should have ay here. That a is missing. So I am going to multiply this by a and divide by a. So this will become 1. This is 1. According to the formula, this is 1. 1 into a, the final answer is a. Now, question number 20, sin 3x divided by sin 2x, limit x tends to pi. So let us use the formula straight away. Sin 3 pi by sin 2 pi is 0 by 0, indeterminate form. So it is indeterminate form. Sin 3x, let us simplify this. Sin 3x is 3 sin x minus 4 sin cube x divided by sin 2x is 2 sin x cos x, limit x tends to pi. Now take out sin x outside, limit x tends to pi, take out sin x out. So you will get 3 minus 4 sin square x divided by 2 sin x cos x. So sin x and sin x will get cancelled. Now apply the limit and check. This will become now, apply x is pi, sin pi is 0. Sin pi is 0 and cos pi value is minus 1. So remember these two values. So it will become 3 minus 0 by 2 into minus 1 because cos pi is minus 1. So the answer is minus 3 by 2. 21, limit x tends to pi, 1 plus sin x, 2 cosecant x. X tends to pi, 1 plus sin x to the power 2 cosecant x. If you apply the limit straight away, you will get 1 plus sin pi. Sin pi is 0 and 2 cosecant pi. Cosecant pi is infinity. So 1 power infinity is indeterminate form. This is called indeterminate form. So let us simplify this. So to simplify this, put sin x as y. So what happens? So what is cosecant x? Cosecant x will be 1 by y. So when x tends to pi, your limit is x tends to pi. When you put x as pi, Sin pi is 0. So when x tends to pi, y tends to 0. Y tends to 0. So this limit will now change to limit y tends to 0, 1 plus sin x is y to the power 2 cosecant x, 2 into 1 by y. So it will become 2 by y. So we can write this as limit y tends to 0, 1 plus y, the whole power 1 by y, the whole square. You know the formula, limit x tends to 0, 1 plus x, the whole power 1 by x, the value is e. So this is equal, this term will become e. So this is e square, the whole square. So we can write this as actually limit y tends to 0, 1 plus y, the whole power 1 by y, the whole square. Question number 22, root of root 2 minus root 1 plus cos x by x tends to 0, root 2 minus root of 1 plus cos x by sine square. Limit x tends to 0. You put the limit straight away, you will get, cos 0 is 1. So this is root 2, this is also root 2, 0 by sine 0 is also 0. So this is indeterminate form. So let us simplify this, multiply by the conjugate and simplify. Limit x tends to 0, root 2 minus root of 1 plus cos x by sine square x. You can remove this root when you multiply by root 2 plus root of 1 plus cos x by root 2 plus root of 1 plus cos x. Multiply and divide by this term. So we can remove the root. So you will get now, we can remove the root in the numerator. Let us see what happens. So root 2, this is a minus b into a plus b. So a square minus b square. So 2 minus 1 plus cos x divided by sine square x root 2 plus root of 1 plus cos x. So that is equal to limit x tends to 0, 2 minus 1, 1 minus cos x divided by sine square x into root 2 plus, so root of 1 plus cos x. Now we apply the limit and check. So when you apply the limit here, put x is 0, cos 0 is 1. So again you are getting 0 by 0 form. If you put the limit x as 0, again you are getting 0 by 0. So we can simplify this further. That is, we can write this as limit x tends to 0, sine square x you can write as 1 minus cos square x, and the numerator is 1 minus cos x, and this is root 2 plus root of 1 plus cos x. So this we can write it as limit x tends to 0, 1 minus cos x divided by 1 minus cos square x, you can write it as 1 minus cos x into 1 plus cos x. This is a square minus b square, a plus b into a minus b, into root 2 into 1 plus cos x. Let us cancel this 1 minus cos x, 1 minus cos x. Now apply the limit. So when you apply the limit, you will get the numerator, nothing is there. The denominator, cos 0 is 1. So this is 1 plus 1. Then you have root 2 plus cos 0 is 1. So 1 plus 1, another root 2. So that is equal to 1 by 2. Root 2 plus root 2 is 2 root 2. So the final answer is 1 by 4 root 2. Or we can simplify this, 1 by 4 root 2 multiply by root 2 divide by root 2. So that is root 2 by 4 into 2, 8. So that's the final answer.